To solve this first example, first of all we note that x obeys a Poisson distribution where the parameter, or if you like the mean, of the distribution is 1.2, and we're asked to find the probability that x is 3, probability that x is greater than or equal to 1, probability that x is greater than 3 but less than or equal to 5. And the first thing we need to do is to remember the formula for Poisson distributions, which is this. Probability that x in some value, little x, is given by e to the minus lambda times lambda to the power x, and that's all divided by x factorial. Now remember, in this situation we're analysing x as a Poisson distribution where the mean, the parameter, is lambda. Okay, so if we can use that to solve this problem then. So first of all, to solve this one, probability of x equal to 3, well, all we really need to do is to sub those values of x equal to 3 and lambda equal to 1.2 into our formula. So here we go. We're going to have e to the minus lambda, so that's e to the minus 1.2 times by lambda to the power x, so that's 1.2 to the power 3, and that's all divided by x factorial, so that's 3 factorial. And what we need to do then is to press a few buttons on your calculator, and out comes the answer 0.086743. Okay, and when in doubt, always round to 3 significant figures. So that's 0.0867 to 3 significant figures. Okay, let's try the next one. Okay, well, just like the binomial distribution, we always want to rephrase these questions so that they're easier to calculate. And if we think about this one, the probability of x being greater than or equal to 1 is the same as 1 minus the probability that x is less than 1. And if you think about that, dealing with discrete values, that's 1 minus the probability that x is 0. Okay, so see if we can work that out. So that's 1 minus, x is going to be 0. We're going to put that into our formula up here. So that's going to be e to the minus lambda, so e to the minus 1.2, and then 1.2 to the power x, and x is 0, over x factorial, that's 0 factorial. Okay, so we just need to remember a few things here. That's going to be 1 minus e to the minus 1.2 times 1.2 to the power 0, or 1.2 to the power 0 is just going to be 1, and 0 factorial is defined to be 1 as well. So that's just 1 minus e to the minus 1.2, and if you put that into your calculator and work it out, you get that that's 0.699 to 3 significant figures. Okay, let's see if we can do this last one. So we're just going to figure out, what does this actually mean? X is greater than 3, less than or equal to 5. Well, let's write that out again. What we mean here really is that x could be 4, or x could be 5. There are only 2 discrete values that are going to work. Okay, so we can quickly work this out then, just using our formula. We're going to have e to the minus 1.2 times 1.2 to the power of 4 over 4 factorial plus e to the minus 1.2 times 1.2 to the power of 5 over 5 factorial, and pressing a few buttons on your calculator should give you that this one is 0.02602, this one is 0.006245. So adding those up should give you 0.0323 to 3 significant figures. Okay, there you go.